We can go ahead and get started. My name is Lance Johnson. I am the VP of Marketing here at Trustgrid, and joining me today is Joe Gleinzer. He is the co-founder and Chief Product Officer here at Trustgrid. And today we're going to be talking about the secret to medical imaging in the cloud and how we can simplify the management of PACS and DICOM image data as it relates to cloud applications. So the cloud has revolutionized pretty much every industry, and it might even sound cliche by now, but it doesn't take away from the truth of it. You know, if you show me an industry that's not leveraging cloud software applications or cloud infrastructure, I'll show you an industry that's ripe for disruption. But just because things are moving to the cloud doesn't necessarily mean that everything is going to. In fact, there's like a lot of things that are not going to be moving to the cloud. Some applications rely on data that cannot move to the cloud, particularly like things like manufacturing equipment or IoT sensors are not going to be able to move to the cloud. Those things need to capture data on-prem. And healthcare applications are particularly prone to this because they need to utilize data from MRI equipment, from CT devices, from X-rays and ultrasounds. And those machines are always going to rely on-prem. They're always going to be capturing data on-prem. But the need to use on-prem data doesn't necessarily mean that we can't move to the cloud. It just means that we need to be a little bit more mindful as we do that. So there are a number of challenges in cloud to on-prem integrations. The first is hardware adjacency. You know, when you're used to running an application on an appliance or on a server that's next to the data, life is pretty easy. It's when you separate those two things that life can become a little more complicated. You know, obviously security and compliance are the utmost importance when we're dealing with medical data, when we're dealing with healthcare records, and we've got regulations around who and what can access and transmit data that sort of limits what our options are there. You know, when connecting the cloud to on-prem, there's going to be a dependence on on-site staffing. And for cloud applications, this becomes a little bit of a challenge because it erodes some of the value prop of the cloud application. And then it also erodes margins for those cloud application providers. And not all data can or should move to the cloud. Sometimes data, especially large data sets like medical imaging data, video, things like that, make the most economical and technological sense to just remain where it's collected and accessed only when it's needed. So how's this been done so far? You know, in pre-internet days, software had to be deployed on-prem next to the local data. So we're imaging dedicated appliances and shipping them on site to simplify this. And as applications started to become more centralized, different solutions are needed. So a lot of apps just needed read-only access, and they weren't changing anything with the data and didn't mind the data being a day or a week old. So they started these batch transactions that would happen at night or happen once a week. And that was fine for some applications that only needed read access only. APIs are obviously the best solution. Cloud infrastructure, cloud applications are based around APIs, but as you probably know, APIs are not always available on some of these imaging devices, which means that we've got to build networks. We've got to build WAN connectivity, and typically this is done with VPN or MPLSs being built to support the bidirectional read-write access that a lot of these applications need. And then, you know, obviously, you know, similar to the first bullet, putting the application or the imaging device near the application is going to be the easiest. But again, that doesn't necessarily work when these two things are required to be separated. So a lot of cloud application providers are sort of combining multiple methods and taking a hybrid approach to this, and they're stitching it all together with a lot of manual, expensive labor. And they're like, well, it's kind of working now, but we would challenge anyone that said that the problem was solved if this is the way that it's being approached. And health tech is ready for the cloud. You know, the promises of faster innovation, of streamlined operations and compliance, greater flexibility and scalability are all really being held back by the challenges that I just talked about. So here's the world view from an application provider's perspective, from a cloud application provider's perspective. You've got a multi-tenanted application running in a public cloud environment, and you've got all of your customers across the bottom. And the reason all of these things are different is because I'm trying to highlight the fact that each one of these is building a separate, unique, different bridge to get the data from the provider's office environment into that cloud application. So provider one is got a VPN. That VPN has a custom config. It's got its own deployment method. It's got its own support needs, and that is different from the VPN at provider two. All of those things are sort of being recreated at the next customer's site. And some customers require an MPLS circuit instead of a VPN. You know, a lot of Trustgrid's customers are using a mix of both of these things across their the portfolio of customers. And again, each one of these things is sort of being managed as a one-off. And the challenges with this approach are, you know, first, long lead times. Anyone that's deployed VPN or MPLS connections know that if you're not waiting on the project team to schedule it, you're waiting on the hardware vendor to ship you the device. If you're not waiting on the hardware vendor, you're waiting on, in the case of MPLS, a telco to turn up the circuit. And these wait times can be weeks and sometimes months. You've got these custom complex configurations. You're having to have dedicated network engineers, certified network engineers, support all of this and deploy all of this. You know, these are hardware-based solutions, so security and compliance comes in to play when the hardware vendors are constantly issuing patches and updates. And, you know, sometimes these things are issued every few weeks, sometimes multiple times a month. And when you're having to manage each one of these connections one by one, you're having to spend time in each one of them, updating them to maintain good standing with compliance. Management and support, you know, if you're managing all of these network connections becomes complicated when you don't have full control of the on-premise network environment. So, you know, having to troubleshoot something, having to support something becomes this sort of multi-layered, multi-organizational challenge. Changing technology, you know, again, hardware-based approaches. You've got hardware vendors that have these planned obsolescence cycles. They force hardware refreshes on you through end of lives. And so before you know it, you're having to update this model number, you're having to update this vendor, and you've got total lack of consistency across all of your deployments. And then, like I mentioned earlier, the need for on-site support negates some of the benefits of operating software from the cloud in the first place. And then you've got the second order challenges that are related to the product. You've got limitations in your features. You've sort of got guardrails on what you can do based on the limitations of the VPN or MPLS that is being used. Scale. A lot of times, you know, well, most times, the reason why you're getting into the cloud is because you want to take advantage of these economies of scale. You know, customer one should be your most expensive customer to support, and they should gradually get cheaper to add zero marginal cost by customer 100 or 1000. The problem is with all of these custom configurations, you're actually going the opposite way. You can manage a few relatively easily, but when you start getting into hundreds of VPN connections that you've got to manage, your costs are incrementally going up as the complexity of managing all of these things increases. And then you've got the expense. You know, the MPLS connections can cost hundreds of dollars a month. VPNs can cost thousands of dollars a year when you combine the hardware, you combine the networking expertise that is required to support those things. And ultimately, these are adding costs to the solution, but they're not necessarily adding value. Customers don't value the fact that you've got to support this network connection. So it's typically eroding margins and can be eroding customer satisfaction with the solution as a whole. So ideally, we're not really thinking about this as a networking or connectivity issue. There's a bigger integration issue to be solved. Instead of building bridges between these two environments, ultimately, we want to manage everything as if it is the cloud. So instead of running everything in the cloud and relying on on-prem data, what if we could run some application components on-prem also? What if those application components that are running on-prem could actually help us dictate what data needed to come up to the cloud and vice versa? So, ultimately, again, we want tighter integration so that the application can become distributed, the data can become distributed, and we have a more seamless experience. And if we can do that without the need for dedicated networking, ultimately we sort of increase the value of the solution, simplify technical support, and we can actually start managing patches and updates and as one big connected environment and manage all of that from the cloud. Having tighter integration between cloud and on-premise environments actually gives a cloud application a competitive advantage. If we are able to cut down the custom configurations, we can scale easier. If we can manage them more seamlessly, we can cut down the time spent deploying and managing network connections and maybe instead focus on the core value of the application itself. And if we can have seamless access to data, we can make our applications more powerful. I mean, the truth is the world now expects everything in real time. And if we have a seamless integration between the application and data, no matter where it's living, we can actually build applications that use real-time, low latency data to make the application stronger. So the question is, how can we achieve better cloud to on-prem integration? And to talk a little bit more through this, I'm going to hand things over to Joe. Joe?
Thanks, Lance. I think you did an excellent job there, I think, laying out some of the fundamental challenges that Trustgrid customers experience when analyzing how to move applications that have been historically installed on-premise into the cloud. And those are exactly the type of customers that Trustgrid works for, specifically in the healthcare industry, specifically doing medical imaging, but also in banking, also in data management and virtualization, also in industrial IoT, and they all have the same challenges. So when Trustgrid has been working with these customers for now more than 5 years to deliver for them the ability to centralize key components of their application, to get the ease of deployment, to get the automation, to get the lack of manual or what Amazon calls undifferentiated heavy lifting off their plates. What they've really focused on is a set of features here that start with networking, that start with connectivity, and start with the ability for a software provider to connect into their customer environments without the need for Cisco or Juniper or next-gen firewalls or a lot of networking experience, a lot of internal resources trying to figure out how to get an IPsec VPN connected from a software provider's data center to their customer's data center. And so Trustgrid really focused on that piece first. We built out what we think of as one of the world's first cloud native SD-WAN solutions. So unlike many other SD-WAN providers that focus on branch office connectivity within a network owned by a single provider, we really focused on these software-defined networking capabilities that extend a software provider's network from a data center or public cloud environment to dozens or hundreds, or in even some cases for us, thousands of customer locations, to do that cost effectively, to do that efficiently and automatically. Part of this, though, is also a reflection that not everything gets moved to the cloud. And so many Trustgrid customers need to run additional software appliances on premise. So connectivity is one piece of that, but there might be hyper-converged infrastructure. There might be dedicated hosts of one sort or another required to operate individual pieces of software. Obviously, in the medical imaging space, that's absolutely required to interface with the devices themselves. And our customers wanted remote control, remote management of those systems. So yes, on one hand, we provide connectivity to them, but then we've also extended the platform to include remote access features. And this is the ability to get access to those other appliances. And then finally, the customers came to us and they said, this is great with Trustgrid Node, helping with a customer. We also need the access. We would like to package these applications as a container. Can you help with that? And that is also what Trustgrid does. And that's why we really refer to this as a distributed application platform. It's the ability for the development team, the operations team, the DevOps team to get involved, to leverage Trustgrid features to solve a lot of these deployment integration challenges and deliver a cloud-like experience for the application you're delivering to your customers. So when we look at this, we mentioned these three pieces in specific because this really is the three fundamental features that our customers are needing in order to allow them to centralize much or all, or in some cases only some of their applications in a cloud or a centralized environment. And right now, obviously, cloud, as Lance was saying, is the big trend. Everybody's going that way. But you probably have as many Trustgrid customers that are still operating in data centers today that have an eye towards the cloud and that look at Trustgrid as a way to bridge that gap. Obviously, if you're operating in a data center today, you probably have some VPN or MPLS connectivity to your customer environments. And that migration process can be pretty intensive. And we talk to folks all the time that have hundreds or thousands of those connections, and moving the application to the public cloud means moving those connections. So that's a real common time to engage Trustgrid, a time that we add a lot of value by delivering on these three major feature sets. So the site-to-site networking, what we refer to as Trustgrid Connect. What you should expect from that is to connect from any public cloud environment. Take your choice there. We are agnostic. All four of the major public cloud providers are supported. In your data center environment, we're supporting Hyper-V and VMware virtual appliance deployments, as well as hardware appliance deployments, to deliver that high throughput, high security, high compliance environment. And we'll dig down into some of the security and compliance stuff here in a bit, to get the remote access that you need, right? And this is done, as we mentioned before, with either an agent or an agentless approach, to be able to tunnel connectivity to applications via SSH or RDP or VNC, or web applications as well, if the web management portal for an app, to a remote user to do that securely with the zero trust security model. And then to deploy these Docker containers at the edge. And our customers, quite frankly, typically are used to operating containers within their data centers or their cloud environments. If they're in a public cloud environment like Amazon, these containers are probably managed for them. And the idea of moving their application into a container really is focused not so much on the traditional container use cases of microservice architecture, but really to get the management capabilities extended out to the edge. And the Docker container just solves some of the basic packaging issues that go along with deployments. And so Trustgrid has that ability with our edge computing features for you to take a Docker container from the command line, push that into the Trustgrid system, and then allow Trustgrid to deploy that application subject to your specifications in terms of blue-green application deployments, staggered rollouts, et cetera. And we're frequently deploying dozens, hundreds, thousands of these containers, and are able to automate and orchestrate that process, all from our cloud management infrastructure. The piece that's most visible of that being the portal that we have shown here in this diagram, but it extends far beyond that as well. There's going to be all of our centralized routing and monitoring of routes for health, all of our security features, the PKI we use to build our TLS tunnels with mutual authentication, all of the log archival and all of the management resources that go into orchestrating and operating this infrastructure, all delivered in a multi-tenant fashion from Trustgrid AWS systems. And important to note there, as we'll see in some additional diagrams coming up, never will your data enter that cloud system. That's strictly for management metadata only. So the type of applications that we see that are good fits for the Trustgrid infrastructure, kind of a paradigm here across the spectrum, but a lot of cloud applications that just have to access on-prem data, where just the ability to ingest that data is what they're looking for. So that's, in most cases, the application can be nearly completely centralized. Other apps are connecting to data sources all over the place. This can be distributed across customer environments. This can be distributed across different data centers. This can be branch offices. This can be manufacturing floors or construction environments. We have some customers in that space. Hospitals and practices and clinics. They need to aggregate that data, typically without replicating that data. They want the access without having to copy it for compliance sakes or privacy sakes. Some applications that require access to very large data sets. We deal with customers that have data sets in the dozens to hundreds of gigs range that are being transferred frequently. And that typically is going to be complemented by a container tool, for instance, like a DICOM tool that allows for compression of those, caching of those files to ensure that the file gets transferred correctly prior to it being wiped at some point in time in the future. And they need to support things like encrypted local storage for that without having to force our customers to do a lot of key management. The ability to enable a device to boot with an encrypted data store on it. All those things are features those customers are typically looking for as well. And then the real-time access to data. This gets into a concept that we refer to around here as a data mesh. These are typically customers that at some point in time have tried to replicate data centrally. Obviously, that's a very difficult problem to solve at scale, trying to move large amounts of data to a single data lake in the cloud. What our customers have typically found is that the challenges of doing so, plus the costs of storing those data lakes, can quickly outpace the really short-term perceived value of doing so. And so they're wanting this access to the data. They want it to be highly available, right? They have very high expectations. Downtime costs them tremendous amounts of money, but they don't want to replicate that data. And so we're able to deliver from a networking side features such as high availability clustered pairs of nodes that can automatically fail over, as well as fail over between public cloud and on-premise environments in real time too. So dynamic routing solutions there that enable the availability that our customers really are demanding from a system like that. So how we do this today, so we refer to this as a fabric of integration, because we do offer a number of different features here that are designed to accommodate the variety of different integration needs we've covered here. All of our customers operate in a multi-tenant environment. From a data perspective, they're providing software and solutions to their customers. We're simply a part of those solutions that they're bundling in to handle the networking piece, to handle the software deployment piece, to handle remote management and administration and add efficiency to that process. And then in some of the deeper features we get into to operate things like APIs at the edge, or to do some API management in a similar fashion to API gateway in the cloud, various providers that offer that. Our customers are wanting layer 3 tunneling here. We also offer a layer 4 proxy approach that's a little simpler and easier. In all cases, these are bidirectional traffic. You'll see a lot of different architectures. Many of our customers, the traffic sources from their data center or cloud and is pulling data in from on-premise locations. In some cases, there's data being pushed up to the cloud on scheduled basis or as needed. But they all are going to have some bidirectional element to this. I find that the customers that are simply just pushing data up typically have some broader options that don't really require the features that we're going to be offering here. But one element that I think goes unnoticed until some scale deployments are reached is the ability to connect down on premise. Even if you're not pulling data up, you'd like to be able to manage or test or help troubleshoot some of those systems, simply because as a software provider that's going to be supporting your customer, you're also stuck supporting their environments. And a lot of times these local issues within a branch office or within a practice office or within a local hospital, they become your problems, right? All of a sudden your software isn't working is the reported symptoms. And in reality, a local issue is going to be the root cause. And we need to be able to remotely access those systems to be able to help provide the data to our customers to prove that it isn't a problem that we are responsible for or can be helpful with really in any way to get them focused on the actual nature of the problem. So here we'll dig down into some architectural concepts. This is a very, very simple architectural diagram of really the connectivity use case, and we'll kind of build on some of these concepts as well. So on the left-hand side, we have an application. This could be, an application allowing radiologists access to imaging data hosted in an Amazon environment or in a VMware private cloud infrastructure and data center. On the right-hand side, we have a remote data source. And for the purpose of this webinar, this is an image generated by an MRI, for instance, or a database hosting those images that are now having to be transferred to the cloud to be able to get that data up there. So a few key points about this one. That Trustgrid node that's on premise in that, say it's a hospital, is going to build outbound TLS tunnels into that Trustgrid gateway. And it does that for a few reasons. Most importantly, it's because we are frequently installed behind firewalls. And we want to make it as simple as possible to get that connectivity established without having to ask the on-premise IT team to do a bunch of port forwards or to make any firewall configurations. In many cases, there's no change required to the firewall at all. If they are blocking all outbound traffic, they will have to whitelist some /28 networks for Trustgrid and probably a few specific IPs for your application as well. I heard this referred to as an inside-out architecture. It works really well for this. And then the TLS tunnels that we use, very firewall friendly compared to IPsec, very low overhead, really been a very effective solution to deliver a full layer 3 tunneled solution here, or layer 4 proxy when appropriate. And then as this diagram is showing, we separate data plane from control plane. So at the top, you see our central management and monitoring infrastructure that we talked about earlier. The data that goes, that patient data of the image that moves from that remote data source to your application is typically architected in a hub and spoke approach. We also support a mesh networking where appropriate. The most important element of that is that it never goes into the Trustgrid infrastructure, the multi-tenant stuff. This is all that data planes dedicated for your use and then can be segmented out for each of your customers as well. So if you're delivering a solution to several dozens, hundreds of customers, within that, a customer might have 50 or 100 locations. Those locations can be permitted to converse in some uses. All that data gets transmitted back to you, but we're enforcing segmentation on that network to prevent customer-to-customer communication there. In that centralized management infrastructure, there is communication from the nodes, the gateway nodes and the edge nodes we're showing here up to that, typically via some TLS tunneling, via API calls. And so we do need to make sure those firewalls are open. And then on your side, I didn't mention, but we are going to have some incoming ports, one for each gateway instance. They need to be forwarded in there, but typically easier to make firewall changes on your side than in a customer environment. Now, we also have some use cases here where we want to extend the functionality of this into the next step, which is the ability to push these containers down on premise. And our customers have a lot of reasons for doing this. Lance covered, I think, many of them before, very specific to each application, but ETL functions that are typically used to operating in low latency environments or these very large data set sizes or with specific security or compliance concerns. The hardware adjacency piece, a lot of times we want communication to be occurring directly to the hardware there locally, but perhaps we're exposing the controls or we're exposing the data transfer there into the greater network. So the ability to push these Docker containers down on each Trustgrid node, I think is an important concept. We definitely get lumped in with the SD-WAN feature set very often. I think it's a fair comparison, but you really need to be thinking of Trustgrid node more like you would an EC2 instance in Amazon, where we have the ability to run really whatever software that we want to on there. We could have multiple instances. We can configure those in a variety of different ways and accommodate really the advanced use cases specific to this medical imaging and similar use cases like laboratory management systems and so on. So the main features that our customers are coming to us for today start really with the deployment problem. Many of them have installed stacks of equipment globally that is very difficult to manage, difficult to produce new versions for, difficult to troubleshoot, difficult to manage, difficult to patch and secure. And there's typically some shared relationship with the customer. And I think overwhelmingly what we are hearing in the market today is most customers really want to be out of that business. They want to be out of the business of running and managing and maintaining software on premise, even when there isn't a method technologically really available to do that before Trustgrid. And so we're trying to solve that problem. How do we get your software package pushed down to a customer environment as quickly, easily, and simply as possible? That is a mix of automation of technology as well as managed services. So in many cases, Trustgrid gets involved to get the network configuration information from a customer, to ship directly to the customer environment, to help them with the deployment, especially in situations where they might not have extensive on-premise IT resources available. And I think even when they do, there's a desire from a software provider's perspective to not have to engage those on-prem IT resources they're busy, they've got a lot of priorities, and it might slow down the installation of your solution by days, weeks, months, or years. Next, we talk about global visibility and control, which is really a single pane of glass for our customers, these software providers, to see all of the network connections, to see all of the instances of their software running, to be able to connect with a single click to any of them, to get logging data and terminal access to these containers, to be able to determine that the system is working or not and respond to it proactively without the use of dozens of individual tools like S&MP monitoring, remote access, VPN configuration. This all gets done in one simple, easily accessible global portal, also available via API, but that also then is able to produce a feature set that really goes beyond what truthfully all of our customers would attest, far surpasses what they were able to stitch together previously with these diverse tool sets. That really leads into the next feature set as well. The continuous updates and improvements, the CI/CD integration that Trustgrid offers. So we get really in line with your development processes as your new versions are coming out of the engineering. We're going to be able to take those new containers and deploy them to your specification where they improve, make sure all of your customers are running the same versions, not rely on that local IT to handle the updates. Part of that is also the security patching of the operating systems, as well as the Trustgrid software simultaneously, and to do that in a way with a very high level of success. And so we have multiple stages of fail back and fail over and the different components there. High availability is, I would say, a very frequently requested feature, but not mandatory. We offer both options to customers with an enterprise class feature set, like I mentioned before, dynamic routing, high availability, disaster recovery, but also a much faster, easier, lower cost method to connect that wouldn't have that available, simply to reflect the fact that some installations pay more than others, right? They have higher expectations than others. We want to be able to accommodate not just those that demand that dynamic routing feature set, but also the smaller branch office that might be acceptable to have downtime for a period of time when they have a single internet connection fail or when they have a single VPN tunnel fail. And then finally, the container management. Really, we're trying to build into the Trustgrid solution the ability for you to dictate the operating parameters of this. So today you can set all the environment variables. You can set all the hardware resource constraints. You can set the deployment modules. You can obviously leverage the layering factors of containers to get just the updates applied that you want without re-downloading the entire thing. Many of the containers that we deal with are quite a bit larger than a typical container would be in a cloud environment, because they are really taking a non-containerized application or a non-traditional architecture for containers, packaging it up into one or two or three containers and pushing it out to get the management features as much as the overall container architecture benefits there. So if we peel back the layers of the Trustgrid solution and look at really some fine points on what's included in there, the value you're going to get. We've talked about the portal. We've talked about the APIs. Trustgrid has an API first mentality here. So before we build a feature in the portal, we're going to build it in the API. We're an open API standard, so easy for you to get an API key and start testing out how that works. We've got a lot of assistance we provide with some of the scripting around that. In the control plane side, we offer identity-based access control. That really comes down to integration to your IDP or your IAM solution, both for the purpose of portal access, but also for the purpose of appliance access. So if you were to connect down to a Linux box on your customer site running next to a Trustgrid node, we're going to be able to authenticate you via, for instance, Google Suite prior to getting that access, display those appliances to your authenticated user, audit and log that traffic, and so on. The virtual networking overlay that we build is the routing, is the tunneling, all that's automated and managed centrally. Key to making that work in this software provider environment is some fairly novel approaches to NATing, because one of the more common challenges that we see with at-scale deployments of these networks between organizations, between the provider and the customer, is overlapping private subnets. And so we've got some pretty interesting solutions around that. I've talked some about the security side of this. From a network security perspective, we do TLS, mutual authentication. So we have both client side and server side certificates. We run all the PKI infrastructure for that. It's a fully managed solution, so there's no pre-shared keys anywhere in that Trustgrid network. We have a full monitoring suite included in this. Many of our customers have legacy S&MP monitoring tools or or fairly advanced solutions and want to continue using those. And we offer integration support for several different products there and standards like SNMP v3. Trustgrid also is going to provide you a full monitoring suite native to the solution that's monitoring at the operating system level, the hardware resource consumption level, networking for latency and circuits that are down, and then the application level and container level as well. Touched on earlier, we handle all the software updates. This specifically is referring to at the OS level and the Trustgrid level, but also applies, of course, to the containers that are pushed down on there. With the Trustgrid solution, like with most cloud native solutions, all configurations done centrally and then deployed to the edge. So all the version management, all the backups that previously have been done with these edge devices really goes away. We're writing to a database first, and then we're sending that data down to the device. And the devices are all incredibly intelligent in how they handle that in terms of health checks prior to and post installation of the configuration, with a variety of failback steps if there isn't invalid information contained there. We talked about remote management of appliances from a remote access, SSH or RDP so far. But really the goal for the Trustgrid solution is to eliminate the need for that sort of access as much as humanly possible. And where not, to bring some of these advanced troubleshooting tools, even things like packet capture, into the portal so that a tier 1 support rep can quickly log in, validate that data is passing, and be able to work with that customer on premise to identify that the root of the problem is or is not within infrastructure that our customers may manage. Container registry, kind of beat that one up, I think, in terms of how containers get pushed to Trustgrid, how we're doing version control and managing those, and then deployed on premise. And then centralized reporting. So all of our customers are subject to high expectations in terms of availability, compliance, and security. We want to give you the tools to not just trust that that's being done, but to be able to report that that's being done, to show to auditors, to show the customers. In many cases, our customers are using us as their SLA source of truth. If we're up, their solution is effectively up, excepting, of course, the data center and cloud side. That's pretty easy for them. And then data plane endpoints. The Trustgrid nodes are really what we're talking about here. These are cloud nodes, all 4 major public cloud providers. A variety of hardware appliances from very inexpensive, x86 architected devices up to very robust solutions in terms of total compute, especially in the DICOM space. There's quite a bit of compute required there at the edge to do some of the caching and compression that gets done before those images get transmitted centrally. We're able to handle that very easily, even with the container deployments. Virtual appliance nodes, Hyper-V, VMware, open source agents. So if we have an admin user attempting to connect into an appliance on premise, he can do that with an agent on his system, an OpenVPN agent or a WireGuard agent, but also then can use our agentless portal for the vast majority of connections, which is just a simpler agentless approach. We're not having to manage an agent on that device. We're not even worried about the device's health for that matter, because that device is never on the network. We're just converting SSH and RDP VNC to a HTML5, and so it's transmitting screenshots. That device could be infected and wouldn't matter to that end appliance. There's no risk there. So some of the benefits that our customers are realizing from the Trustgrid solution, the application flexibility is far and away the most important to them. The ability to run in the cloud what they want to run in the cloud, what is optimized to run in the cloud from a latency perspective, a cost perspective, an architecture perspective, but the ability to support legacy integrations and legacy code that's operating in a data center still or on premise, and solve some of these challenges about hardware adjacency, security, compliance, latency, and so on, that really makes on-prem a right fit for a lot of different software applications, regardless of how modern they are. Security and compliance is obviously a big deal and becoming a much bigger deal. The Trustgrid network with our zero trust security model really goes far and above what most folks have done with VPN or MPLS historically. And then compliance solutions like GDPR and data privacy legislation are a big deal for our customers, especially once you start centralizing applications that may serve many countries or political jurisdictions. The ability to leave that data within Brazil for Brazilian customers, or the EU for European customers, Canada for Canadian customers, California in the US for Californian customers is becoming more and more relevant and critical. And then the ability, of course, to manage that data using a variety of tools to fulfill your obligations under those same GDPR compliance requirements, or so on. And availability for customers that have historically deployed on-premise, the LANs are highly reliable. When we introduce firewalls and then WAN connections and then remote data centers and cloud environments, we're introducing some complexity, and there are typically periods that all of our customers went through prior to Trustgrid where availability was a challenge for them. They overcame those in many pieces, but the VPN has been consistently a weak link on there, especially when they've historically deployed VPN connections into their customer environments, leveraging customer equipment. So when the customer provides a next-gen firewall, does an IPsec tunnel to your infrastructure, I don't know anybody who's been happy with that solution's availability, but Trustgrid's dynamic routing, the high availability pairing, the centralized monitoring of these connections, the ability to quickly and automatically reroute that is going to give you a level of availability that really is difficult to achieve using any other solution. And then simplified operations, as Lance hit on really earlier, operating an environment like this at the scale that our customers are, dozens, hundreds, thousands of connections and deployments, is a massive investment in manpower, a lot of advanced skill sets involved, and unfortunately, frequently advanced skill sets that are underutilized. High-end network engineers that are stuck trying to troubleshoot a remote VPN connection might take 6, 8, 10 hours for a difficult problem, and they're not able then to work on the higher value tasks for which they are also responsible. And then finally, cost. Everybody's cost sensitive, and that certainly is a realization that Trustgrid has. We go toe-to-toe with what the router and firewall vendors, all the big names you can imagine for similar solutions that are typically network only. And we come in very competitive with those, all the way down into some of the lower and next generation firewall vendors. We do price this based on a subscription service, and the ability to leverage the x86 architected hardware really makes that cost down to a minimal amount when you aren't able to use virtual appliances and so on. So we think Trustgrid is the most effective way to integrate that cloud infrastructure to the on-premise environment. I think you'll find that we leverage a lot of the cloud concepts that you are familiar with or gaining familiarity with quickly to make the deployment and integration of Trustgrid to your solution as simple and easy as possible, and to leverage the same experience that you are expecting in those public cloud environments, to really abstract away a lot of that lower end work that can take up so much time, but adds very little value to your customer's experience with the application. Our goal is to make the edge of your application in that customer environment, those on-premise environments, as automated and as efficient and as simple as the cloud has done for you in those centralized environments. So a little bit about Trustgrid, just a snapshot here. Over 2,000 installations and counting. I got a few thousand more under contract that we're rolling out this year with our customers. More than 1,000 customers total now running Trustgrid software. We are SOC 2 Type 2 compliance. HIPAA obviously comes up quite a bit. Introduces some very interesting challenges when you're installing software in your customer's customer environment, right? So some software runs in our customers' data centers and cloud environments, but they're taking a Trustgrid node into their customer environments who have their own security compliance expectations. And SOC 2 Type 2 is a globally recognized standard that gets us through a lot of those doors without a lot of work. This year we'll do, it says $3 trillion. I think the last estimate I heard here might be as much as $4 trillion of transactions over Trustgrid networks this year, all behind the scenes, but obviously trusted for some of the most important data there in the world. More than 40 million users this year are going to log into applications that Trustgrid behind the scenes is delivering that data, that real-time data that is needed to power those applications.
Great. Well, that was it for the presentation. We've got a few questions here, 3 to be exact, but if you have any additional questions, keep them coming in. Let's sort of walk through these, Joe. The first one is, do you currently have customers managing DICOM image data on your platform?
Yes, yeah. So that's a fairly common use case for us. The use of a DICOM application that is doing the caching compression on a Trustgrid node.
Okay, the next one is, can you give an overview of pricing and packaging?
Yeah, so there's really three costs to consider with Trustgrid. Um, the first and easiest one is the hardware appliance. So we're not in the hardware business. Our hardware either comes with a Trustgrid logo on it or with our customer's logo on it, but it's all made. It's x86 generic hardware. We don't engineer any hardware. And so we want that cost to be as low as you want it to be. And it can be from providers like Dell and HP. Those all get to throw a hat in the ring here from time to time. So very flexible in the hardware, and the hardware just costs what the hardware costs. Typically, it still is the easiest way to get software installed at a customer site is a prepackaged appliance. Also, virtual appliance is free. There's an installation fee that typically gets charged on a per site basis if you want Trustgrid to handle the installation at your customer sites. That is the solicitation of the IP information, network configuration, that sort of stuff. Our customers, some want that and some don't. So that could be a zero. And then the subscription fees. So each node has an annual recurring subscription fee. And it comes in at about $80 a month, priced annually there, about $1,000 a year per site for a single node.
Okay. You might have answered this one. What sized hardware appliances do you support, and how much compute can your appliances handle?
Yeah, I think we covered that some earlier too, but down to, I think our smallest appliance right now is about 150 megabits a second of encrypted throughput. Those can be $350 in that range, so fairly inexpensive, up to very large deployments with multiple processor, 6428 gigs of RAM, high speed disk, really anything in between. That the hardware to Trustgrid is, we're built on Ubuntu Linux, and so as long as Ubuntu can run on the hardware, we're pretty comfortable with it. There's going to be some constraints there that we run into, but we have customers with very large throughput requirements on virtual appliances in the cloud, and then very large on-premise as well.
And last question: do you support deployments in Europe, and what about GDPR and local country-specific legislation?
Yeah, so we're really flexible with that one. So absolutely deployments in Europe, no problem. And then as relates to GDPR and data localization, we separate the data plane from the control plane. So on one hand, we're giving you the tools so that a centralized application operating in an AWS region can leave data at rest in those specific countries where they might need to avoid having to replicate it into a centralized location. So we are providing our customers tools to deal with that. And then Trustgrid never has access to that data plane. So we never are able to view the health information or banking information or other information on the data plane. All we're ever dealing with is metadata, essentially anonymized data about the system, how it's operating, the bytes being transferred, the ports and IP addresses, and so on. So we really stay out of the GDPR game, but our customers are able then to segment that traffic in a way by political zone to make sure that that data is only going where it's supposed to be, even if they're operating an application that's consuming some of that data outside of that space. That's a great question, that last one.
Great. Well, that was it for the questions. Again, appreciate everyone making the time today, and look for this presentation in your inbox either later today or early tomorrow. And if you would like a personalized demonstration, you can go to trustgrid.io for more information. There's a request demo button on those pages, and we'd love to hear from you. Thanks, everyone.
Thank you. Take care.